Hi everybody. In this video we are going to derive a couple of these what I call the circle equations, c equals pi d and c equals 2 pi r. What it means to derive something is just to take what we already know and figure this out. Okay, so how can I figure out that these equations are true? Well, let's start with something we already know from a previous video, which is that if we take the circumference of a circle and divide it by its diameter, divide it by the circle's diameter, then we get pi, which is just a number which is a little bit bigger than 3. And that is true of any circle, no matter how big it is. Now, what if I wanted to just get the c by itself in this equation? What would I do? Well, just like any other equation, I would use inverse operations. So for example, if I had an equation x over 7 equals 11, and I wanted to get the x by itself, I would get rid of the 7 by multiplying, because this is division here, and the inverse of division is multiplication. So I would divide both sides by 7, and the 7s would cancel out over here, and I would get x equals 11 times 7, which is 77. Okay, we're going to do the same thing over here. If we want to get the c by itself, then we need to get rid of this d over here. And the way we're going to do that, since this is division, since the c right now is being divided by d, we would do the inverse of division, which is multiplication, and we would just multiply both sides of the equation by d. These d's would cancel out over here, and we would just get c equals pi times d. We could just write that as pi d. Okay, and then that's it. And we have just derived this equation over here, c equals pi times d, or c equals pi d. Okay, now to derive this one, we need a little bit more. So let's take another look at these pictures over here. So we have a circle over here, and then we have the same circle over here, and this is the radius of the circle, and this is the diameter of the circle. Now, I know that the radius of a circle goes from the center to a point on the exterior, and I know that the diameter of a circle goes through the center and connects 2 points on the exterior. It's not hard to see that the diameter is exactly twice as big as the radius. In other words, if I were to take this radius over here and just sort of let the line keep going like this. Let me make that a little bit thicker. So I just start from here, and then here's the radius. But if I were to continue that with this other radius over here, then these two so radii is plural for radius. These two radii over here, if I put them together, the length of the two radii would be exactly equal to the length of the diameter. Okay, so the length of a diameter of a circle is exactly twice as big as the length of the radius, and we could write that in equation form as d equals 2 times r. So this is saying that the diameter of a circle is, so if we're sort of reading an equation, sort of like translating it from math into English, then you can read the equal sign as the word is. So this is telling us just what we said a minute ago, which is that the diameter of a circle is 2 times as big as the radius. Okay, so that's all it's saying, and hopefully it should make sense from this picture over here. Now, to derive this other circle equation, what I'm going to do is start with this one over here, which we derived earlier. Let me just keep that on the screen. So I'll start with this equation, c equals pi d. But since I know that the diameter of a circle is just twice the radius, I can plug 2r in for this d over here, because d is the same thing as 2r. 2 radii is the same thing as 1 diameter, right? The length of 2 radii is the same as the length of 1 diameter. So I can just replace this d with 2r, and then I would get c equals pi times 2r. So all of these things are getting multiplied together. And because of the commutative property, we know that the order that we multiply numbers in does not matter. So for example, 5 times 3 times 2, well, 5 times 3 is 15, 15 times 2 is 30, right? I could put this in any order and I would get the same answer. So let's try 2 times 5 times 3. 2 times 5 is 10. 10 times 3 is still 30, right? So the order doesn't matter when we're multiplying. So C equals pi times 2r is exactly the same as C equals 2 times pi times r. And that's how it's usually written. And that's how I have it written over here. Okay, so those are the first two circle equations that we're going to derive, okay? They're the only two that we're going to derive in this video. We'll save area for another video. The last thing that I want to say for this video is, what do these equations tell us? What do they really mean? Well, these equations tell us that the circumference of a circle is a little more than 3 times as long as the diameter, and a little more than 6 times as long as the radius. Okay, so just like I said earlier, when you see the equal sign, you can just read that equal sign as the word is. So this equation over here, and also remember that pi is just a number which is a little bit bigger than 3, right? So this equation is telling us that the circumference of a circle is a little bit more than 3 times as long as the diameter, okay? And this equation over here is telling us that the circumference of a circle, well, actually, the first thing I should say is that if pi is a little bit more than 3, then 2 times, what's 3 times 6? What's 3 times 2? It's 6, right? So if pi is a little bit more than 3, then 2 times pi should be a little bit more than 6. So 2 pi is a little bit more than 6. So this equation here is telling us that the circumference of a circle is a little bit more than 6 times as long as the radius. Okay, here's the radius over here. The circumference is a little bit more than 6 times as long as this. And here's the diameter of this circle over here. The circumference is a little bit more than 3 times as long as the diameter. Again, if we were to take a string and then measure all these things, you know, then that's what we would find. Okay, so that's it, and have a great day.